Hello, my name is Beth Dixon, and this is a video series based on Vicki Borlaug's PowerPoint presentation on the combinations, permutations, and fundamental counting. I wish to thank Mrs. Borlaug for allowing me to use her PowerPoint to make this set of videos on counting. This is the fourth video in this series, and I anticipate that I will finish this PowerPoint in this video, but that is dependent on the time, because I do plan to keep this video within my time limit. Our next example uses both fundamental counting principle and combinations. There are 25 different videos, 10 different books, and 20 different CDs in a store. You are planning to buy 4 videos, 3 books, and 7 CDs. How many ways can you make your selections? First, think about what our question is asking and how we can break down the problem to accomplish finding the answer. We have multiple tasks to complete. First, we want to buy videos, then books, and then CDs. I love that Mrs. Borlaug gave us this picture to use to complete this problem. When I tutor, I like to draw something too. It helps me to picture something and helps me to show the students how to visualize a structure for the problem. We have 3 tasks to complete, and the number of ways each task is completed will be multiplied. This will give us the total number of ways to make our selections. Start with task A, which is selecting videos. We need to buy 4 videos from a group of 25 videos. Since we are buying videos, we do not want to repeat videos, so we would not use the fundamental counting principle. Since all of the videos are going home with us at the same time, order would not matter. Does it really matter if the clerk puts Thor into the bag before the Avengers, or the Avengers into the bag before Thor? No, the order of the purchases does not matter. So this is a combination. We have 25C4. Remember, 25 is the total number that we're choosing from, and the total number we're choosing from always comes first. The number we're selecting from that is the second number. So that's 25 choosing 4 is another way of saying that. Likewise, Task B is selecting books, and we are selecting 3 books from a total of 10 books. We do not want to repeat books, and order is not important. This gives us a combination, and from the 10 books we are choosing 3. 10 choose 3, or 10 combinations of 3. Our last task, Task C, is to select the CDs, and we will choose 7 CDs from the selection of 20. Again, no repeats, and order is not important. That gives us 20 choose 7, or 20 combinations of 7. 20 being the total, 7 is the number we select out of that total. Notice in each case I ask myself the question of, are there repeats, and is order important? Next, we need to complete the calculations. So you simply complete the calculations with your calculator, getting each of those 3 combinations and then multiplying those 3 combinations. Notice your calculator will give you an extremely large number. Your calculator may even say e to the 11th as opposed to times 10 to the 11th, and then you just move your decimal over 11 places, and we'll need to add some extra zeros there. So there are Oh dear, let me see if I can figure this out. 117,675,360 ways to select 4 videos, 3 books, and 7 CDs. When doing probability, what type of answers do we get? We get answers between 0 and 1. When doing counting problems, these answers will be very large whole numbers. Here is class questions 5, 6, and 7 for you to try. We can also use counting to find probabilities. Here is an example, and it has 3 parts. In doing a problem with multiple parts, I read through the problem once and then I concentrate on one part at a time. Like eating an elephant. How do you eat an elephant? 1 bite at a time. A club consists of 5 men and 4 women. The club is going to form a committee of 3 people. Question A says, how many ways are there to select a committee of 3 people? B asks, how many ways are there to select a committee of 3 men? And then C asks us, if a committee of 3 is randomly selected, what's the probability that it consists of all men? Back to what we have. We have a club, and it consists of 5 men and 4 women. So we have 9 people in our club, and some of them are men and some of them are women. Next, we have a task. That task is to make a committee of 3 people. How many ways are there to select a committee of 3 people? That would be every committee formed, whether it's a man or a woman. How many different committees are there possible from these 9 people? Well, since it's a committee, we have to ask ourselves the questions that I go through every time in my counting problems. Repeats. No, we cannot repeat. Repetitions are not allowed. Is order important? No. It doesn't matter whether you're chosen first or second. There are no job titles or distinguishability between being on this committee first, second, or third, in this case, since we're selecting 3. Since repeats are not allowed and order is not important, this means we have a combination. So that would give us, from the 9, we have 3 combinations from that 9, or 9 combinations of 3, I guess I should say, or 9 choose 3. If you put that in the calculator, you will get 84. Think before we go on. Whoops, wait a minute. Question B. Well, no, think before we go on, before we get to question B. What do those 84 committees look like? Some will have 3 women, some will have 3 men, and some will have a mixture of men and women. In our 84 different committees, that's all of our different possibilities. That's every way that there are to do it. Some with men, some with women, some with combinations of men and women. And not the combinations that we're talking about here. So it's probably a bad choice of words. So B, how many ways are there to select a committee of 3 men? Well, this is sort of like conditional probability. We know that we're only dealing with the men. So we are looking at just the 5 men on the committee. So since we're looking at the 5 men, the conditions on the question are the same, other than the fact that we're only dealing with the 5 men. We have no repeats and order is not important, so we're still dealing with a combination. The issue is, instead of choosing from all 9 people, we can only choose from the men, so that would be 5 combinations of choosing 3. And so from 3 select 3 from the 5. That's 5 combination 3, and that would give us 10. This would be 10 committees made up of the 3 men selected from the 5 men. If a committee of 3 is randomly selected, what is the probability that it consists of all men? Well, there are 84 different committees from this club, and the men themselves have 10 committees amongst themselves. So the number of ways to select a committee of 3 men divided by the total number of ways that a committee can be selected of 3 people from the club would be our probability, or 5C3 over 9C3, which would give us 10 over 84, and again doing the calculations would give us 0.1190. Again, notice because it's asking for a probability that the answer to C is a number between 0 and 1, whereas questions A and B are asking how many, and they are large whole numbers. Let's do one more example before we close out this video. A closet has 7 shirts and 5 pairs of pants. 4 of the shirts are yellow, 3 of the pants are brown. How many ways are there to select a shirt and a pair of pants? How many ways are there to select a yellow shirt and a brown pair of pants? And then lastly, if a person randomly selects a shirt and a pair of pants, what is the probability that it will be a yellow shirt and a brown pair of pants? We'll approach this problem very similarly as we did the previous one. Think about our sample space. We have a closet with shirts and pants. 4 yellow shirts, 3 brown pants are part of the closet. How many ways are there to select a shirt and a pair of pants? We would just use the fundamental counting principle to find out the number of ways to select from the closet regardless of color. That would be 7 ways to choose the shirt times 5 ways to choose the pants, or a total of 35. Next, we need to think about just the yellow shirts and the brown pair of pants. Since there are 4 of the shirts are yellow and 3 of the pants are brown, there's only 12 ways to have that combination of colors. So if a person is randomly selected randomly selects a shirt and a pair of pants, what is the probability that it will be a yellow shirt and a brown pair of pants? Well, the number of ways to select a yellow shirt and a brown pair of pants is 12 over the total number of ways to select from their closet is 35. So that would be 12 over 35, which would give us 0.3429. So let's do one more example. I thought that was the last one, but there is one more. A club consists of 5 men and 4 women. The members of the club are Tom, Dick, Harry, Sam, Jack, Becky, Vicki, Linda, and Sue. The club is going to form a committee of 3 people. How many ways are there to select a president and a vice president and a secretary? Well, how many ways are there to select a president, a vice president, and a secretary? Well, in this case, That right there tells us that they're job titles. And because we're picking with job titles, repetitions are not allowed and order is important. So we have a permutation, and from the 9 we have 9 pick 3, which would be 504 ways to pick 3 people from the 9. If the president, vice president, and secretary are randomly selected, what is the probability that Linda is president, Harry is vice president, and Becky is secretary? Well, that's just one arrangement. So that would be 1 out of the 504. The number of ways to have Linda as president, Harry as vice president, and Becky as secretary over the total number of ways to arrange these things, which we just did in part A as 504. And that gives us 0.0020. Here are class questions 8 and 9. And thank you for watching. I did finish up. I probably should have divided this into 2, but I did finish it up with just a tick over my time limit. I do have other videos on probability that may be of some help to you as well. And as always, if Walter State students are welcome to stop by and see me in MBSS 222 in the math lab.